Okay, hey, welcome to part 3 of our video series on the, I guess we call it the Honda Acura idle speed control, math channels, and duty cycle. And we have a still shot in front of us. This was captured a little while ago. You remember from the first 2 videos, we had 4 scope signals and 2 math channels. Our black math channel is the duty cycle, and our, what color is that, sort of magenta? That is a math channel for, I guess we call it RPM/frequency, taken from the crank signal, which is in orange. Our duty cycle signal is in blue. Basically, the gist of this section of the video, we're going to talk about just the AC on, AC off. What I'm doing here is I'm turning the AC compressor clutch on and off, and obviously the PCMs knows that, and it will command the duty cycle to increase to give the engine more RPM to deal with the load of the AC compressor. So what I'm going to do is I'm going to get rid of the green channel and the red channel. They are basically the power steering pressure switch, and the current flowing through the pressure switch, just to give us a little cleaner screen here, make it not so congested. So I'll right click, go to channels. We're going to go to let's go to C. We want A, we want B, and we want C out of there. Okay, so now we see we just got our duty cycle here in black for the IAC solenoid, and we got our RPM in magenta. So basically, this is me just turning the AC on and off. We can see the effect that the AC has on the system. When the AC comes on, our duty cycle, and remember, our duty cycle is going, when it's going down, it's going up. A little paradoxical there, but that's just the way I set the math channel up. It is a ground side switch component, and the software is under the assumption is positive side switch. That's just my inability to really set that math channel up the way I wanted to, but nonetheless, you can see a duty cycle swing here, and we can also see an RPM swing here. Let's go down the line and see another section of it. Here's our RPM swing in here in magenta. That is the math channel, and it's definitely affected by the duty cycle change. Right here we can see another one, RPM going up on magenta. Let me give that some stretch for clarity. Right here, there's our RPM swing. You can see that right there going up. Our duty cycle went up, as you can see here, and that load of the AC probably lowered the alternator output slightly. So we had a little less charging voltage, so it was able to catch up over here. So nonetheless, we can definitely see I'll kind of key in on the duty cycle, and we'll talk about, we can actually, if we didn't have the math channel, we can actually see with the difference in, as I showed before, that we have more on time here than we have here. And I'll kind of key in on that so you can see it, basically here to here compared to here. So that's just the PCM, kind of a game of input-output. The PCM sees an AC request, it grounds the AC compressor clutch, and the PCM has to tell the IAC motor, or the PCM itself will increase the duty cycle on the IAC motor, and there'll be more air flowing past the throttle plate. So basically, this is just a deal. We're just looking at the AC command to the PCM. I will go to another capture, and we'll take a look at another situation in this video, and the effect of idle speed controlled by the PCM. I'm going to do something called IAC disconnected PCM. I'm going to talk about that, and I think there's some value there as we look at this. Okay, what do we got? Okay, this is IAC disconnected at PCM. Take a look at your schematic, which you probably have from part 1. As you look at that schematic, if you don't have it, just go back to part 1 and take a screenshot of the schematic, and probably save it, put it off to the side as you watch this video. It'll make it a lot easier to understand. We have a look at the purple connector at the PCM. Little purple arrows indicating like a male and female connector. Okay, oh, we got some screen issues. All right, we'll just have to deal with that. I'll have to move carefully. Look at where our test points are on channel A, the blue channel. If we are either in front of that connector or behind the connector. When I say behind, I mean closer to the PCM. That will affect our signal if that connector should become unplugged. Let's say we had a pin fitment issue. It's coming back, folks. All right, come on. If we had a pin fitment issue at the PCM terminal that controlled that duty cycle solenoid, our test point would tell us a lot about where that circuit is open or compromised. So just take a look at that test point. If you look at the screen right now, the test point would be on the, if that became disconnected, our test point would be on the PCM side of the connector, not the IAC side of the connector. As you can see, the voltage go low, and I'll key in on that. Let's take a look, and we can see right here, it became disconnected, and our engine's still spinning. Our IAC is unable to make any duty cycle. Okay, hang on. Hello, hello. Hello. Okay. Car warranty. Anyway, we'll keep going. Okay, take a look at our duty cycle. There is no duty cycle. I'm going to put a speed math channel here just to see that we didn't see any effect on speed. I'll go to right down here to frequency D and on, and you can see as we key in here, we do see a change in math. Look at the swing of that RPM. Okay, that has got to be something else is causing the RPM to move right there. That's kind of interesting. Just take note of that. Okay, the duty cycle can't do anything. It's at one position. It's just the current. There's no current flowing through the duty cycle. The throttle plate has no electronic control. This is not a drive-by-wire car, and you can see that swing in there. That the PCM says I don't have any connection to the IAC motor. That's got to be timing doing that. I'm saying with 100% certainty, but there's nothing else. Nothing can physically move the throttle plate. I know they wouldn't use the cruise control cable. That has some electronic capability, but I would take it to the bank they are not. That has got to be timing adjustments that the PCM says I can't control the engine speed through the IAC anymore, so it's probably doing something to the timing. As you can see, that magenta math town just swinging up and down. See those, looks like teepees, on a reservation. You can see one after the other. That RPM is doing some swinging, and that's got, as I said, I can't think of anything else that could affect that other than timing. So that's an interesting capture there. I just want to point out something. Take a look at the red channel on the screen, and then revert back to your schematic. And I told you when we're going to flip a channel, on channel B, we've moved away from the power steering pressure switch, looking at that amount of microamps, and I put the amp clamp on the wire from the IAC motor to the PCM with the arrow pointing toward the PCM, as you can see on your schematic. So I'll show you the relationship between voltage and current. This is before it gets disconnected. We'll key in on this. It kind of says us a lot about voltage and current. And we can see, okay, here's our voltage and current. This is before I disconnected it right here. We're ground side switch. So when the circuit goes low, when the driver closes at the PCM, that's when current flows. And I'll kind of stretch that so we can see that and see the relationship between voltage and current. It's pretty clear right there how much we're drawing. That is the current flowing. That is stop flowing, stop flowing, and about as much as, let's kind of get an idea of how much current's flowing. I delted the top to bottom in red, looking at about 3.6 millivolts. That converts into milliamps. These idle solenoids don't draw a whole lot of current. That's I originally had a regular low amp clamp on. I couldn't get much range. That's what made me switch to the micro clamp. But nonetheless, you can see that that current is flowing. We got a good clean brake. The driver's crisp. It doesn't drop any voltage to the point where I disconnected the idle IAC motor at the PCM, and then we have no current flowing. Obviously, we have an open circuit, and you can see the RPM math channel change. That's most likely due to timing. So anyway, that's the end of part 3 of our Honda Acura idle speed control, math channels, and duty cycle. It's a tactical technician from Dog Nation signing off. Thank you very much for watching.